Hello dear students, from today I will start vector algebra chapter 10. Okay, so this is new concept for all of you, vector algebra. So there are some basic concepts and basic definitions. So just we have to know the what is vector and scalar and type of vectors, scalars, and there are some special type of notations for vectors. So let's start one by one. So here for vector algebra we require first of all the definition of vector quantity. What is vector quantity? Having magnitude and directions, just as we know from also our previous class. So here just see, this is a line segment, not line segment, this is line, directed line. It is called directed line. This direction is from this A to B. Okay, so this is, we can say this is a line. Okay, directed line, maybe direction like this also. And how many distance in this line, or what is the length of this line, it is not given. So also this is line. Okay, directed line having some direction. Okay, but we know if a quantity having direction as well as magnitude here, if we take 2 points here, A is here and B is here, so A to B there is some distance, so this is magnitude of this line segment. This is line segment, AB line segment, AB line segment, and direction is this. So this distance, that is the magnitude of this line segment, magnitude, and also direction from A to B, called vector. So vector quantity, what is vector quantity? Having directions and magnitude both. Okay, and scalar quantity, if a quantity having directions but not magnitude, or having magnitude but not direction, yeah, you can say that is scalar quantity. Okay, so here just, if this is a line segment AB, so just we denote AB vector. Its terminal point is this and initial point is this. This is initial point, start from A, and this is terminal point. Terminal point. Okay. So vector notation we can do like this. Direction is this. If its direction like this, suppose B to A, then we write vector BA. Its initial point is B and terminal point is what? A. Why it is notation? Okay. Position vector. Up now, suppose we have two-dimensional plane or three-dimensional plane. We know also, just we also introduced with 3D plane, 3D space, and here 2D plane. If there are 2D plane or 3D space, okay, so we can just define position vector of a point. Suppose there are 2D plane. Suppose 2D plane like this. In this space, two-dimensional vector we can also define. This is origin. Suppose A is a point. Suppose A is a point. Okay. Then, if we join this OA and direction give like this OA, then OA is a vector. This line segment, directed line segment from O to A, so OA, and here O is origin. Here two-dimensional origin. This, and we know that distance between 2 points as a original by using formula. So we can find here formula magnitude, distance. So distance will be magnitude and direction from O to A. This is vector quantity. And position vector. This is called position vector. Whenever O initial point is origin. Initial point in origin and A is the pointer. Then we can say that this is position vector of A. Position vector of point A. Position vector of point A. Okay. And also in 3D diagram we can define in 3D space position vector like this. Okay. So here just take position point in 3D point. Here also in 3D space we can take our previous idea, just like suppose these are 3D space, x axis, y axis and z axis. Clear? This is origin. Now suppose there is a point in space just like P, x, y, z, rectangular coordinate. Then we can draw perpendicular from here to xy plane. Suppose this is P1. Clear? Then we can draw the diagram. How? Just this is OP, position vector of P, OP, position vector of P. Okay. Now also take just parallel line to here, just like this. This is point, similarly parallel line to this. Okay. Now also parallel line to this. This. Now from here we can draw like this line parallel to this. Okay. Like this is point B, this point B, this point A, and also just parallel to this line we can make parallel line to this, just like this. Parallel to this. Okay. Now here this line also can be drawn. This line can be drawn, and one more line. This is this. Okay. This is x. This is y. This is z. This length is z. Clear? This length is z, that is this x, this is x, this is y, this is y. Just total is y. This is our direct diagram. We know. Here, line from this. So, from this line, this triangle, just like corner to parallel line. Okay. So here we see that this is the angle. What? OP, position vector of x. This makes with x axis angle alpha, suppose, and this is alpha, this is 90 degree, this angle is 90 degree. Okay, because from this position vector, just draw perpendicular here. So this plane, just draw this line. So this line, axis, and this 90 degree. So this is 90 degree. So this OP is what? OP is hypotenuse. X is base. That means like just like this. Suppose this is AP. This is A, this is P, and this is O. And X means here, this is X and makes angle alpha. This angle alpha, and this is perpendicular. This is OP, R vector. This is denoted vector R. Okay, vector R. This is denoted vector R. Clear? Vector R. And this is alpha angle. This line makes angle alpha with x axis in positive direction. Okay? So alpha. So we can write cos alpha equals to base by hypotenuse, base x by hypotenuse r. Okay? This cos alpha equal to x by r. That is what? X equals to r cos alpha. X equal to r cos alpha. Okay. So here vector r. R means its modulus. Just vector modulus of vector r is denoted by like this. Just we know what is modulus. Vector r is by using also Isaac K unit vectors along x-axis, y-axis, z-axis. Just we know if we use in this direction unit vector, and also we know that if A is a vector, then its unit vector is denoted by a cap. A cap means its modulus will be 1. A cap means unit vector means modulus magnitude is 1 and having some direction. So here if in the direction of x-axis we take a unit vector, that is I cap. I cap is a unit vector, its modulus. This modulus is equals to what? 1. And its direction is unit length, that is equal to 1 in this direction. Similarly, in this direction, we know j cap in this direction, k cap. So if we denote this length, then we can write by vector law of addition of vectors r equals to xi plus yj plus zk. This is, and then modulus of vector equals to root of x square plus y square plus z square. Also we know that the difference between these 2 points 0 0 0 0 x y z 3D distance root x square minus y plus y square plus z square root. This is modulus r equals to modulus of r. So modulus of r is equals to this from here in 3D. So here mod r means small r. Small r equals to root of x square plus y square plus z square. From here we can see that r square equals to x square plus y square plus z square. These are the basic relations. Just remember it. Okay. So r is vector, position vector of P. So here by using this concept, if x OP vector r makes x alpha angle with x axis, positive direction x axis, similarly make beta angle with y axis, and similarly gamma angle with z axis, then we can get relation just like this, where alpha, beta, gamma are what? Angles which makes by position vector r with x axis, y axis, z axis. And here I, j, k are their usual meaning. So vector position vector is r is equals to what? xi, yj plus z k, we know. Okay, we know x, y, z are the scalar component, and xi, yj, zk are the vector components of this vector, and its modulus is this. Okay, so just use this concept. Here we see that if alpha, beta, gamma are the angles which makes by r with x axis, y axis, z axis, then we can get relation like this. For alpha this, similarly we can get relation for beta and gamma. So here we see get cos alpha equals to what? X by r. Cos beta equals to y by r. Cos gamma equals to z by r. That is what? X equals to r cos alpha, y equals to r cos beta, and z equals to r cos gamma. This are getting. Where alpha, beta, gamma are what? Alpha, beta, gamma are angles which makes by the position vector of P with x axis makes angles alpha, beta, gamma, makes by position vector in positive direction. Okay. Also, this alpha, beta, gamma, cos alpha, cos beta, cos gamma are denoted by L, M, N. These are called direction cosines also of this vector, of this line, OP line, LMR. So we can write also x equals to LR, y equals to MR, and z equals to NR. This LR, MR, NR, just we can write LR, MR, NR. What? LMNR what? Cos alpha, cos beta, cos gamma. Alpha, beta, gamma are what? Direction angles for this position vector. Okay. So position can be also written as LR, MR, NR. Okay. So where element are direction cosines, cos alpha, cos beta, cos gamma. Alpha, beta, gamma are angles making by this line. Okay, these are the position. This is position. Coordinate. This is also coordinate can be written like this. Go x equal to LR, MR, NR, theta. And here also we see that r square equals to x square plus y square plus z square. So r square equals to x square means L square r square plus m square r square plus n square r square. So here we see that r square taking common and then cancel out from both sides. So we can get L square plus m square plus n square equals to 1. Where element are what? Direction cosines. Element are what? Direction cosine. So L square plus m square plus n square equals to 1. Direction cosine. The square of sum of direction cosines is equals to always 1. Okay. So remember this also. So these are the basic concept. Okay. So direction cosines means cos alpha cos beta cos gamma. And the relation between direction cosines and coordinate x, y, z, alpha, beta, gamma are this. Just remember it for solving questions. Okay. So these are the direction cosines. And direction ratios is another concept. Direction cosines and then direction ratios. Okay, these are the direction cosine. The cosine of the direction angles. Cos alpha, cos beta, cos gamma, 11 are direction cosines. Now direction ratios. Direction ratios are the quantities which are proportional to direction cosines. That is LR, MR, NR are direction ratios. Means some quantity, if there are some quantity A, B, C, these are three quantities that are proportional to element. Okay, that means if there are three quantities, suppose, so A by L, B by M, C by N, means quantities which are proportional to element are called direction ratios. Very important concept, both direction cosines, direction ratios. Direction cosines are quantities which are proportional to direction cosines. Clear? So here we see that if we take LR, MR, NR in place of this LR, MR, NR, then we can see that LR, MR, NR are in this place, in ABC, in the place of ABC, that is A, LR, B, MR, C, NR, upon L, M, upon N. So L can see, so R equals to R. That is what? In place of A, in place of B, in place of C. So LR, MR, NR are the quantities. Also here R times. So these are the quantities which are proportional to element. So this is can be also treated as direction ratios. What? LR, MR, NR. That means x, y, z can be treated as a direction ratios of this vector. X, y, z means what? Position vector. Suppose we are given a point 1, 2, 3, 4 and O is this origin. So this is OA, vector OA. So its direction ratios will be 2, 3, 4. 2, 3, 4. So direction ratios are quantities proportional to direction cosines. And here we see that by theory that x, y, z may be treated as a direction ratios for this vector. For this vector, x, y, z may be treated as direction ratios. So this is the concept of direction cosine and direction ratios. Okay. So remember this concept, very important for solving questions. They are very important. Okay. Now, just we will discuss about what types of vectors. Okay. So just before that, here just take some previous idea. Sum of two vectors and how can we sum two vectors and what are the rules for adding vectors or types of vectors. Just type of vectors means there are different type of vectors. Means first of all, zero vector. What is zero vector? Zero vector means A means magnitude 0. That is terminal point and initial point are same. So A to A. If AB is a vector and if B tending to A, that means both coincide. AA, zero vector can be defined like this. So its direction is, what is direction? Maybe any directions. But magnitude is 0. Okay. Then unit vector, just if we have a vector C to D and this is unit length. This is unit length. This length is unit. That is vector CD is equals to 1. Modulus means magnitude of vectors is 1. Then it is called unit vector. And direction is from C to D, unit vector. Okay. Now, co-initial vector. Co-initial vector means, suppose we are having three vectors. If this is a vector, suppose this is denoted by A. This is another vector denoted by B. So initial point are same, A to B and A to C. So AB is a vector and AC is also a vector. Initial point are same, so co-initial vectors. Co-initial vectors, if their initial points are same. Now collinear vector, equal vectors, negative of vectors. Collinear vectors. Collinear vectors are very, very important. Collinear vectors means if we have two vectors and they are parallel to same line. Suppose there is a line. Suppose there is a line. And here is a vector A. And also another vector is B. And this is a line. This A and B both are parallel to this line, same line. If the vector A and B are both are parallel to same line, then we can say that A and B are collinear. Here, both are parallel to same line. Now, there is nothing says about direction. If its direction may be in this direction, maybe in this direction. Direction may be different, and also magnitude may be different. It is its magnitude. It is its magnitude. Magnitude also may be different. Direction will be also different, but they are parallel to the same line. Okay, so they are called collinear vectors. Okay. Because both are parallel, then we can write vector A equals to vector B some times of scalar quantity. Okay, scalar quantity. Maybe a scalar equals to, this may be any real number, negative or positive, because sometimes vector A may be greater, this is smaller. So maybe A is equal to lambda may be less than 1 value, and if their direction different, the lambda may be negative value. The lambda is positive, then they are both directions are same. We can write like this: both will be same if its direction same and modulus same, that is lambda equals to 1. Plus then same direction, minus then different direction. Okay. So these are linear vectors and collinear and equal vectors. Vectors are equal if their corresponding components are same. Okay. If magnitude and direction both are same. Two vectors are equal whenever have the same magnitude and same direction. And also if the vectors are given in component form, then their component should be equal. Then we can say the two vectors are equal. Same magnitude, same direction, and also in the component form, components are same. And we write in that case two vectors are equal. Clear? Now, negative of a vector. Suppose we have a vector in that like this, A to B. Okay? So vector AB, this is vector initial point and terminal point. Negative if its direction we take just like B to A. Just like B to A. Then B to A means magnitude same, but that its opposite direction. A vector whose magnitude are same of a given vector, but its direction will be opposite. Then we can say this is equals to negative vector. So BA is negative of AB. BA is negative of AB. Because its direction from A to B, but its direction from B to A, opposite direction, but magnitude same. So BA equals to AB, we can write like this. That is CD vector equals to minus DC, negative vector. Clear? So we can express some statement notation. Just first of all, for before solving 1.10.1 exercise, just we have to discuss about addition of vectors. Okay. Here, addition of two vectors given by triangle law of addition. Just like, because generally we are using the vectors of free vectors. Free vector means suppose here is a vector A and here is a vector B. Its initial point is this and its initial point is this. We can use this vector here just with initial point here. Just draw parallel line parallel to this. Magnitude same, with same magnitude we can draw here, because free vectors means vector can be drawn anywhere but taking its parallel, and this point go to here and this point go to here, just parallel. Okay, parallel means like this. Okay, up to this. A can be taken here. So any of the vectors can be free vector means it can be drawn in anywhere with its parallel replacement. Okay, with same magnitude. So for adding two vectors, suppose there is a vector A and just another vector which initial point is here, we can draw like this, B up to here. Then we can use OAB. Then we can see that OA plus AB, that is, we can just direct write vector OB equals to vector OA plus vector AB. This plus this equals to this, direct we can write, triangular law. The addition of these two can be given by vector B, this triangular law. Okay, addition of triangular law of addition. Similarly, if a parallelogram we are having, its two adjacent sides are given by vector A and given by vector B, then we see that this is vector B, this is parallel, so it can parallel to vector B. So these are two parallel and initial point can be transferred to here. So we can see that it's O, A, B, C. So A, this is B, B. So this is can be written as what? A plus B. Similarly, if this is A, then it can be written as A. So A, B plus A. Here also, from here we can see that B plus A equals to A plus B also. Okay, this is in this direction, in this direction. So from this we can also see that A plus B equals to B plus A, because it's diagonal. Addition of, here is parallelogram law of vector addition. Vector addition, parallelogram law. If two adjacent sides are given by A and B, then this is A, this is B, so B can be transferred to here, so AB, AB. So diagonal is given by the addition of these two adjacent side. Also, in this direction, if we take, then B plus A equals to A plus B. In this direction, A plus B equals to this, that is A plus B equals to B plus A. Here, commutative law, we see that hold also. Okay, these are the rules for addition of vectors. Now, here, just this is commutative law. Now, associative law is also hold. A plus B plus C, you know, A plus B plus C. Just we can see that first of all, for getting B plus C, just suppose this is our vector A, this is our vector B, this is our vector C, because all vectors are free vectors, so we can transfer to vector as our requirement. Initial point of vector A is here, initial point of vector B is here, initial point of vector C is here. Just for first getting B plus C, so just we can in this direction, in this direction, in this direction, just we can write like this: O, A, B, C. Here we can see that B, C, this is given by B plus C, triangular law. Now, A plus B plus C, A plus B plus C is given by this OC. OC, what? A plus B plus C by triangular law. By triangular law, B plus C means this is, by triangular law, A plus B plus C is this is this. Clear? Now also, we can see that A plus B plus C is equal to also this. How? If first of all we take A plus B in this diagram, A plus B, just like this. A, OA, this is B, B, this is C, this is C. Just first take this. By triangular law, this is A, this is B, so this is A plus B. Now take this. So first of this plus this is equal to this, that is first A plus B, C. So this and this is equals to. So associative law also hold for addition. Okay. Similarly, just we can add vectors here. Just 2-3 things. Associative law true and commutative law true, and also here additive identity. What is additive identity? Additive identity means we know if vector A, if plus vector, zero vector is also denoted by just zero vector. It is also denoted by zero vector because its modulus is 0. So A vector plus zero vector equals to also zero vector plus A vector is equals to what? A vector. So 0 is additive identity. Okay. Additive inverse. What is additive inverse? Additive inverse is negative of a vector. Just we know, if A is a vector, then its negative is denoted by like this, opposite direction, same magnitude. So we know A plus minus A equals to what? 0 vector. Minus A plus A. 0 vector. Additive identity. This is additive inverse. Additive inverse. That is, additive inverse is what? Inverse of A is minus A. Negative of A. Additive inverse. Okay, so additive inverse, additive identity, addition law, and now multiplication of vectors. Multiplication of vectors. Suppose we are having a vector like this, AB, denoted by A, and modulus is equals to 5, suppose. Its modulus. Some time of this vector means some time of this vector means maybe 5 times A, 6 times A. That is, this is modulus of A. 5 times of a vector. It's 5 times means it's a scalar multiple lambda times or 5 times. Means what? A new vector which modulus is 5 times of the given vector. 5 times of the given vector, and direction is same as given vector. That is scalar multiple. Okay? And lambda, if lambda is negative, then its direction will be negative of the given vector. Okay? This is scalar multiple. Okay. Now, from here we see that if a scalar quantity, suppose we are given a vector A and scalar, just we take a scalar, take. Its modulus is some value, nothing, 0, not 0. A such that modulus is not equal to 0. Then take scalar quantity just like 1 upon modulus of A. Then lambda A modulus is equals to what? Lambda mod of A equals to 1 by mod of A into mod of A equals to 1. That means it is unit vector. It is unit vector. Clear? This unit vector is denoted by what? Lambda 1 by A, vector A, vector A. This is unit vector. Unit vector. And it is denoted by A cap. And the direction is what? In the direction of A. In the direction of A cap, A vector. In this direction. Because this is a vector having direction. So, in this direction, unit vector is this. That is denoted by A cap. That is this upon modulus of A cap. This is the definition of unit vector. If we are given a vector A, then it's in its direction, means in a particular direction, in the unit length vector. How can you find? The vector divided by its modulus. That is unit vector in this direction. Okay. Now, components of vector, just we know, component of vectors in okay, up to unit vector, just here solve. Just we are now solve 10.1 exercise. Very simple. 2, 3, 4 questions are there only. So just complete this exercise by solving. Very simple exercise is there. 10.1. Represent graphically a displacement of 40 kilometer 30 east of north. Graphically you have to represent. Just suppose these are direction. North is here, south is here, east is here, and west is here. So this is 90 degree. Just a displacement of a 40 kilometer 30 degree east of north. East of north. Of north, east means this. East of north. East of north means this. In this direction, 30 degree. 30 degree. And 40 kilometers. That is, suppose O A. 40 kilometer means one section. 10 kilometers. One part. 10 kilometers. So this is 40 kilometer displacement, and OA displacement of 30 degree east of 40 kilometer displacement. 40 kilometer displacement of 30 degree 40 kilometer displacement OA. OA 40 kilometer 10 10 10 10 40 10 kilometer. So 40 kilometer displacement 30 degree east of north. This is the displacement. First question. Clear? This is a graphical representation of this vector. Now, second question is very simple here. What? Classify the following measures as a scalar or vectors. 10 kg, scalar, only magnitude. It involves only magnitude. 2 meters northwest. There is direction and also 2 meters. Magnitude and direction. Both involved. So, vector quantity. 40 degree only. Scalar quantity. Magnitude. 40 baht. Scalar quantity. Only magnitude. 10 to the power minus 19 coulomb. Also, scalar quantity 20 meter per second square. This is vector quantity. Okay, both involving distance and magnitude and direction. Okay. Classify as a third question also. Classify the following as a scalar and vector quantity. Time period, scalar quantity. Distance, scalar quantity. Force, vector quantity. Velocity, also vector quantity, having direction, magnitude, both involve. Work done, scalar quantity. So here in the question 4, just identify the following vectors: co-initial, equal, and collinear, but not equal. Okay, so simple direction is diagram is given. Just you have to identify which are co-initial, equal, and collinear, but not equal. So here just like this. AD and BC. Clear? BC. So co-initial, these two vectors A and D. Which for this two vector A, vector D, initial pointers same. So they are co-initial. And second, equal vectors B and D, because D vector and B vector having same magnitude and direction are also same. B and D are equal. Third, collinear but not equal. Collinear but not equal. Collinear but not equal. A and C. A and C. Collinear because they are parallel to same line. But direction are different. It's not equal. They are collinear, but their direction is same. But not equal. For not equal, A and C. Okay. So 10.1 exercise is very simple question, just logic based. Okay. So A and B, B and D, A and B. First of all, A and B are collinear. And A and C are collinear but not equal. B and D. Okay. So A and C. C are collinear but not equal. Okay, but these are also collinear but equal. Okay, so not equal. Now question fifth, here also given, just we have to give the answer either true or false here. Vector A and minus A are collinear. Vector A and minus A are collinear. True or false? Collinear vector means both vectors are parallel to a single vector, parallel to the same line. So if this is vector A, then this is also vector minus a vector. That is, they are parallel to same line. So collinear true. Okay. For collinearity, both vector must be parallel to same line. So parallel to same line, they are parallel. So true. First is true. And second, what is second? Second is here, two collinear vectors are always equal in magnitude. Two collinear vectors are always equal in magnitude. This is collinear vector AB. This is collinear vector CD. Both are collinear. Why? Because both are parallel to same line. So they are collinear, but its magnitude is this and its magnitude is this. Different. So false. Two vectors having same magnitude are collinear. Two vectors having same magnitude, it is also false, because two vectors having same magnitude are collinear. If it's, suppose magnitudes are same here, CD, magnitude same, AB and same, and its direction is this, its direction is this. Okay, so two vectors having same magnitude are collinear. It is not required, just magnitude is same, but vector may be like this. CD. Magnitude same, but they are not parallel, not parallel to same line. So also this is false. Third condition. Maybe their directions are different. Maybe their directions are different. Magnitude may be same, but direction may be different. Or not direction. Yes, direction may be different, so not collinear. Now, fourth, two collinear vectors having the same magnitude are equal. It is not required. Direction may be different, so not equal. So it is also false. So there is a very simple concept. Your questions given in exercise 10.1. So just revise all the things just we have discussed now. I am discussing now and solving. Write the concept and just answer of these questions and send me for your attendance. Just give your attendance by writing some questions and sending PDF file to me. Okay. So remember it.